Very good morning, students. Welcome to IIT and NEET Foundation, or Focus C program by Krishnaveri Talent Schools and the Mastermind Schools. So once again, I welcome all the class 6th students for today's session. As you all well aware and you can see on the screen, my subject is physics. We are in class 6, our ongoing chapter, laws of motion. And today we are entering to the second session of the chapter. So we started this in the last class, that is on Tuesday, where we discussed about the Newton's first law. We discussed about the Newton's first law of motion. So these laws are proposed by Sir Isaac Newton to know about the, after knowing about the cause of motion. So after studying about the motion by most of the scientists, out of anxiety, they want to know what is the reason behind the motion. In that case, while studying, the Newton is the first person to identify that the force is the responsible for the motion of a body. Based on that, he proposed a group of 3 laws, which are popularly known as Newton's laws of motion. So in last class, we discussed about the Newton's first law of motion in details with various examples also, right? So what is the Newton's first law? And this first law explains about the one word, important word again, inertia. So we discussed what is the measure of inertia, what are the types of inertias, like inertia of rest, inertia of motion, inertia of direction. So as per the Newton, every body is continuous to be state of rest or uniform motion until an external force is applied. It's a simple observation you can do anytime. Means until you apply the external force, body is either maybe at rest or maybe moving with the constant or uniform speed. Right? So there won't be any change in the body state without applying the external force. That statement is clearly given as a Newton's first law. And for further explanation, he told that this is the property actually. Why body is not changing its position? Because it is an internal property of the body called inertia. So inertia is the inherent property of the body by which it cannot change its position either from rest to motion or motion to rest or direction also. Such property is known as inertia, and that is the reason Newton's first law is known as law of inertia. It is also known as law of inertia because it gives the birth to a new word called inertia. Right? So mass is the only measure for inertia. Greater the mass, greater the inertia. Right? Okay? Then you also explain what is force, how it is responsible for the inertia. So many examples we have seen. Right? Suppose when you are traveling by bus is at rest, you are sitting in the bus. Along with the bus, you are also at rest only. But when driver starts the bus suddenly, we feel a jerk. Why you are doing jerk? To come from rest to motion. Our body is unable to change the position, especially upper body. Lower part is anyway, it is on the seat only. But upper body unable to change from rest to motion. For that, it is a jerk. Similarly, when bus is going with great speed, sudden brakes are applied. Then also you can find the front jerk. Will fall down, fall front because of inertia. When a bus is taking turn also, either right turn or left turn, will bend. Why you are bending? Because your body is unable to change the position until unless you are applying the force. So force is nothing but either it changes or tend to change the state of a body. Either body may be at rest or body may be moving. It can be changed by force only. Right? So force is the cause of motion. Force is the cause of rest. Right? That already we discussed in the earlier class, last session. So then we discussed about the, so force can do a lot of things. Not only change of, force can change the shape, force can change the size, force can change the speed, force can stop the body, force can change the direction. Such a wonderful word force is, which is discovered by Newton. Okay. Then we discussed about the types of inertias. Already I told inertia at rest, inertia of motion, inertia of direction. Three types. Already so many, I told the bus example. So many examples are there where we can understand the concept of inertia. Okay. So many examples also given. Yesterday we discussed. You might have written in the notebook also. So this is about the entire picture about the what we learned in the last session, right? Last class. Now we'll move to the today's session. Newton's, that is synopsis 2. Newton's second law of motion. Newton's second law. So it is also called as law of momentum, or law of force. Anything. Relation between force and momentum is given by this law. Law of momentum or law of force. Right. Point number 1 today. So Newton's second law of motion is also known as law of momentum or law of force. Why? Because this law explains about the relationship between momentum and force. So anyway, you know about the force, but let us know about the momentum. So what is momentum? You can see here. Quantity of motion possessed by a moving body is known as momentum, or the total quantity of motion in the body, that is mathematically given by P is equal to M into V. The second point you can note. So momentum is equal to mass into velocity, right? Momentum is equal to mass into velocity. So greater the mass, the P is the symbol for momentum, which is equal to mass into velocity. The product of mass and velocity is known as momentum. So mathematical expression is there, right? So if you want to give the more momentum, more force is required. So this momentum depends only on the force. So when you say units here, mass is measured in kg, velocity is measured in meter per second. Kg meter per second, or you can write gram centimeter per second in CGS system. Any of this you can write as unit of the momentum. Right. So Newton's second law shows the relationship between force and momentum. That is the reason it is also called as law of momentum or law of force. So momentum is nothing but the product of mass into velocity. Mass into velocity, which is measured in kg meter per second or gram centimeter per second. Right. That's what given here. Up to here clear? Now we come next point. Change in momentum. First note on these 2 points. First, then move to the change. Point number 1, point number 2. Or you can write up point number 3 also, units. This make it as units, point number 3. Units of momentum. Right. So we understood what is the momentum. Mass into velocity. Now we'll see what is a change in momentum. Means there should be a change, means there should be 2. Initial, final. That we'll discuss now. First to complete these 3 points. Newton's second law of motion is also known as law of momentum or law of force, which is mathematically given by P is equal to M into V, mass into velocity. Units of momentum are kg meter per second or grams centimeter per second. Okay. Now you can copy from here, misses. Now when you come to the next point, change in momentum we are seeing here. That is, you can see here. Change in momentum. Change means, for example, mu is the initial momentum. First initial. Body is having the momentum of mu. And it is increased. It is increased to mv. mv is equal to final momentum. Means here u is equal to initial velocity, v is equal to final velocity. You know, mass never change. Mass is same only. So what is change in momentum? Change in momentum is equal to mv minus mu. That is initial minus final. mv minus mu. Correct or not? Change in momentum is nothing but final momentum minus initial momentum is called change in momentum. But for this change, for example, a body of mass some 1200 kg, like car or lorry, they are started with the velocity of u. When it started with the velocity of u, its initial momentum is m into u. After some time, velocity increases to v. Then final momentum is mv. Then what is the change here? mv minus mu will consider as a change in the momentum. Right? But during this time, to change this momentum, there is time taken. We cannot stop the time. So, to change the momentum, time is taken. So, we can call it as rate of change of momentum. Rate of change of momentum. What is rate? Means when rate comes, you have to consider time. That is mv minus mu by t. T why you are considering? Because time will take to change the velocity from u to v. It takes t seconds. That is the reason rate of change of momentum is given by mv minus mu. According to the Newton's second law, Newton's second law states that so force is directly proportional to rate of change of momentum. F is directly proportional to mv minus mu by t. That is a statement of Newton's second law. The relationship between force and momentum, change in momentum. The force applied on a body is directly proportional to rate of change of momentum. Rate of change of momentum, right? That is F is proportional to mv minus mu by t. So that is point number 5 you can write. From this you can get the formula for force. So fourth point is mu is equal to initial velocity. You can note down. Mu is equal to initial momentum. mv is equal to final momentum. Change in momentum is nothing but mv minus mu. Rate of change of momentum is nothing but mv minus mu by t. But when you come to the fifth point, but according to Newton's second law, the force, an external force applied on a body is directly proportional to rate of change of momentum. That is, F is directly proportional to mu minus mu by t. So after writing this, we'll move to the next one. Right. Complete fifth point. Okay. So see, second, if you come to second law derivation, second law states that the rate of change of momentum of an object is directly proportional to net force applied. That is, F is proportional to mv minus mu by t. Point number 6. So this can be done. F is proportional to m, you can take common, m into v minus u by t. Right. So m we have taken the common. So you can write v minus m into v minus u by t. But what is v minus u by t? Rate of change of velocity, which is nothing but acceleration. So f is directly proportional to m into a. In place of this, we wrote an a. Or f is equal to some constant into ma. Or simply f is equal to ma, because practically k value is measured as 1. It's called proportionality constant, which value is taken as 1 experimentally. So f is equal to ma is the second law of motion, which is the most important formula in physics, which is connected to first law of Newton as well as for third law of Newton also. So according to the Newton's second law, an external force applied or applied force is directly proportional to rate of change of momentum. That is, F is proportional to mv minus mu by t, or F is proportional to m into v minus u by t. But what is v minus u by t is nothing but a. That is rate of change of velocity. We already seen the definition of acceleration. So F is proportional to ma, or F is equal to k into ma, or simply F is equal to ma, which is the derivation for Newton's second law of motion, which is known as law of force or law of momentum. So write down 6 point, very important point. Copy that point number 6 of second law. Then we'll move to the next part. Right? So what we learned till now? We learn about what is momentum, what is force, and what is the relationship. Relationship is nothing but equation between change in momentum and force. First we know about momentum, then change in momentum, then force. These two are directly proportional. So we got a popular or most popular for mathematics physics formula, F is equal to m into a, mass into acceleration, which is measured in. So under point number 7, you can write units also. Right? Force is measured. See, mass into acceleration. What is mass? Just a minute. Okay. Mass, you know, we measure in kg. Acceleration is meter per second square. Kg meter per second square, or you can measure in Newton, name of the scientist. Or you can measure in CGS system, you can measure in dyne. Unit of the 1 Newton is equal to 10 power 5 dynes. Huh? 10 power 7 maybe 7. Relation also there between CGS and MKS. So, 6th point is force is measured in kg meter per second square, or you can get gram centimeter per second square also, or simply Newton or dyne. So this is a complete picture about the Newton's second law of motion. Second law of motion. So before going for further, I will show you one video on Newton's second law. Right. First you watch that video. After writing this 7th point, you can note on the 7th point also. After writing this, we'll move to the one video on Newton's second law, which is also called as law of momentum or law of force. Right. Now, just to see the first video. After that, we move to the next topic. Right. Watch the video on Newton's second law of motion.
In this video, we're going to learn about and practice applying Newton's second law in calculations, relating force, mass, and acceleration. You have just thrown a ball, and it's travelling upwards. neglecting air resistance. What force or forces are acting on the ball? A. The upward force from your hand. B. The downward force of gravity. Or C. Both of these. The answer is just the downward force of gravity, which gradually slows the ball, stops it, then brings it back down, making it fall faster and faster. The unbalanced force here causes the ball to change its velocity. Now look at this ball thrown sideways, but with elastic attached. The force on the ball must be towards the hand, caused by the piece of elastic, which slows it down and then brings it back to the hand. This is just like the ball thrown upwards, except that it's the force from piece of elastic that slows the ball and then brings it back. What else could happen to an object when subjected to an unbalanced force? When forces are unbalanced, objects can speed up, slow down, like the thrown ball, but also change direction. Think of trying to change your direction on a muddy football field. Normally, you dig your boot into the ground to provide the force to change your direction. But in the mud, you just carry on in the same direction, and you call it a skid. The larger the mass of an object, the larger is the force needed to change the direction or its speed. Think of trying to push a car compared with a bicycle. Also, the faster you want something to get moving, the bigger the force needed. Think of pedaling a bike. The harder you push, the quicker you get going. The relationship between force, mass, and acceleration is known as Newton's second law of motion. It can be summarized in this equation.
T.
Resultant force equals mass times acceleration. When force is measured in newtons, mass is measured in kilograms, and acceleration is measured in meters per second. A spacecraft with a mass of 7,150 kilograms accelerated away from the International Space Station towards its re-entry point with an acceleration of 2 meters per second relative to the International Space Station. Calculate the resultant force on the spacecraft. Pause the video and work it out. How about this example? A car of a mass of 1,200 kilograms starts moving and accelerates on a racetrack. The car's engine produces a constant force of 3,400 newtons.
What is the acceleration?
A constant frictional force of 400 newtons acts on the car. Calculate the acceleration of the car. Pause the video while you work it out. Now calculate the force required to make an 800-gram toy car accelerate at 8.2 meters per second. Take care with the units.
Right.
And the mass of an object accelerating at 0.8 meters per second when a resultant force of 200 newtons acts upon it.
Okay. So he clearly
why do you think
he clearly explained about what is the Newton's law, second law, and how to get the different methods. Suppose when the mass is given, acceleration is given, how to get the force. Suppose when force is given, acceleration is given, how to get the mass. When the mass and force are given, how to get the acceleration by using the same formula. By using same formula, we can find the so many values. All the 3 values you can find out from known values. Known values, using known values, you can find out the unknown values, right? So this is, see, this law can be also represented by one magic triangle. I will tell you. Okay. Say this is a triangle. We want formula F is equal to MA, right? F, M, A. Sometimes what happens, we know the formula F is equal to MA. right? Suppose F is given. F is given as suppose 200 Newton, right? A is given as 2 meter per second square. Asked to find what is the M. So generally we'll confuse what is the formula for M. This most of you are confused. M is equal to either you have to write F by A or A by M. F you are confused definitely. In such case, we can use this triangle, magic triangle. This is given by the Ohm electricity. You want formula for M. Place hand on the M. M is equal to F by A. Can write F by A. If you want formula for A is equal to F by M. Or F is equal to M into A. So any formula related to three physical quantities, we can use this magic triangle. Means to avoid the confusion, there is nothing magic is here, but to avoid the confusion while solving the problem, right? So just you can avoid the confusion by this triangle, this magic triangle. Okay, I'll give once again. So whether you want to find A or M or F, just simply you can write like this. Right? Triangle, divide it, one more division, into you place here mass, acceleration, and F. Whichever you want to find out M, place thumb on M, will get F by A. If you want to find A, place thumb here, F by M. If you want F, M into A. Like that you can do. So what is the mass here? Mass is equal to F by A. What is F here? F is given by 200 by A is nothing but 2. 200 by 2, that is nothing but 100 kg. Mass not kg. So like that by using this triangle, say take point number 8, you can write. Okay, magic triangle. So you want to find any of this physical quantity when other two are given. We can use this simple triangle method. Okay, see they given the complete derivation what I already told for you. F is equal to MA we got. A is equal to V minus U by T. So we got the formula F is equal to MA by end of the day. So this is completely the second law of Newton. Okay, Newton's second law. So there are units also given, units of force. Absolute units of force are mass into acceleration, kg into meter per second square or Newton or dyne also. Gram centimeter per second square or dyne. Newton or dyne. Right. So there is a Newton, this definition is also given for Newton and dyne. Just simply from the relationship also given, see 10 to the power 5 only. 1 Newton is equal to 10 power 5 dyne. 1 Newton is equal to 10 power 5 dyne. You can write as a 9th point. 1 Newton is equal to 10 power 5 only. I told 5 first. 5 dyne. Very important relation. It is derived here. Okay. Okay. Now when you come to the part of gravitation, with respect to gravity, force will change. So that force is called gravitational force. Gravitational force is nothing but the force with which Earth is pulling the body towards itself. Every body when you are throwing upwards, definitely will come back because of the gravitational force. Okay. Gravitational force is responsible for bringing the body downwards. Such force is called gravitational force. So gravitational force is measured in kg weight. Right? Kg weight. Or kgf you can call it as. Kg force. That will come across in the next. Okay. You can write that also as a 10 point. 1 kg weight. Gravitational force is measured in kg weight. So this is about the complete picture of the Newton's second law of motion. Newton's second law of motion. So which clearly explains about, then some more is there, gravitational force, CGS units. You can make it as a point number 10. Okay, this is point number 10. Gravitational force CGS unit is given by. Right? So with this, we have finished the Newton's second law. So what we learned today? First we start with what is force, what is momentum, what is change in momentum, what is the relation between momentum and change in momentum. That is going to be Newton's second law. External force applied on a body is directly proportional to rate of change of momentum, or the rate of change of momentum is directly proportional to applied force. mv minus mu is proportional to F. From that we got equation F is equal to ma. So that is measured in Newton or dyne. 1 Newton is equal to 10 power 5 dyne. Right? And if it is in the case of gravitational force, that is given in the kg weight or gram weight. 1 kg weight or gram weight, you can measure gravitational force. Right? This is a clear picture about our total second law. So far we completed Newton's first law and Newton's second law also. So before going for third law, one more important point is there. One more important concept, impulse. Impulsive force is also one kind of force only. Right? Is also one kind of force, impulsive force. That is given by I is equal to force into time. Very, very important force in many applications. Force into time, or simply you can write as change in momentum. Change in momentum. That is mv minus mu. I. How you got this one? mv minus mu. See, in same case, I is equal to F into T. You can write, F is nothing but mv minus mu by T. According to Newton's second law, rate of change of into, again one more T is there. So T cancel. We'll get the I is equal to mv minus mu only. It's also derived from second law. So impulsive force is nothing but it is a force into time which is obtained from Newton's second law. Means if you increase the time, force will reduce. That is indicates. Time increases, force reduces. For example, you see when in a game of cricket, when the fielder is taking a catch, he will take the hand backward. He will withdraw the hand backward for taking the catch. Why? Because you want to increase the time, more time to take the catch. So speed of the ball decreases. Force of the ball otherwise you will get injured. So when you are increasing the time of contact, then automatically the force will reduce. Such force is called impulsive force, which is obtained same from Newton's second law. You can see there F is equal to ma. We know ma is equal to v minus u by t. mv minus mu by t. So impulse is nothing but F into t. F into t is nothing but mv minus mu, change in momentum. So change in momentum, it is measured in Newton's second. Force in time, force in Newton, force is Newton, and time is in seconds. Newton into second. So point number 11 is this. Point number 12 is units. Units are nothing but I is equal to F into T. F is measured in Newton and time is measured in second. Newton's second is the unit for impulse or dyne second. Right? Clear? So this makes the total explanation for the Newton's second law of motion. So in next class, when we meet, we'll discuss about the Newton's third law. Everybody know about that. Newton's third law. That is, for every action, there is equal and opposite reaction. What is happening in Ramnagar branch? You are doing some experiment. Okay. So next class, we'll discuss about the next week when we meet, we'll discuss about Newton's third law. It's a very, very, very important law in our day-to-day life. So far, we finished with the two laws. Newton's first law and Newton's second law. And both the synopsis we completed. We'll do the third synopsis in the next class. So till then, you can write the homework, daily practice problems. State and explain Newton's second law of motion. State and explain Newton's second law of motion. Write down the homework and write in your notebook take the signature from your class teacher, subject teacher, simultaneously with same time with your parents also. So once I'm reminding, 28th of this month, last Monday of the month, we have the test 4. Test number 4. Already question papers might be received by you. Conduct the test number 4, which is cumulative syllabus. The total syllabus what we covered till now. First chapter, second chapter, and third chapter Newton's law. All 3 are there in the next exam, which is on 28th October. Note down the date, log the date, and write well, prepared well, and write the exam. Same pattern, everything is pattern, number of questions are same only, but syllabus is all the 3 chapters what we covered till now. Right. So thank you very much, all of you. Have a wonderful day. Thank you. Thank you, each and everyone. Good to see. I don't know, 8th Mass, Alwal KTS, Farhan, Indresham, Gurimalkapur, Ramnagar, Umar Rani Garu, Swarup Nagar, Masterminds Karmanghat, Masterminds Palaknama, ECIL, Varasiguda. Thank you, all of you. Have a wonderful day. Thank you.